Namaste, good morning. Again we came with the new topic. Last time we have already seen the latch, today the flip flop. Flip flop using SR NOR gate. So, see, you all guys, my dear student, I think you will enjoy today and you will learn a new thing, because in last chapter we have only seen the latch. In latch there was no any external devices are used. In this there is the clock. And what is the clock? So, here the clock pulse is used for the synchronization of the circuit. In our digital system, all the system they are only know the 0 and 1, and the device, this is the device which can store 1 bit, that may be the 0 or that may be the 1. And in computer memory there are a lot of latches and flip flops are there. So, how they will coordinate to each other? So, to synchronize that, this clock is necessary. So, we have added the additional control signal to control those all the gates. This to control all the gates, we have used here the clock. The next point, in the clock flip flop, the output can change a state when the clock is high. Only when the clock is high, then only this will change their state from 0 to 1 or 1 to 0. When the clock is low, the output remains in the same state. That means, whatever the output was there always, there was 0 or 1, that remains in the same state. The next point, we want a control to change the output in subsequence, that is the clock. So, this is the minimum thing about the clock. Now, here we have added the extra 2 AND gate. This is the already you have studied in the last lecture. This is known as SR latch using NOR gate. And I have made the truth table of SR latch using, here is the truth table of NOR gate. We will see what is happening. We have already seen when the 0 0, that was the whole condition. Suppose there is S dash and this is the R dash point. I have made one point because here is the S and R, that so. So, you know very well what is happening, and that I have written in this truth table. Now, this is the extra 2 gates. Suppose this the name of this is AND number 1 and this is 2, already this is 3 and 4. So, here one thing that was the question for you, I think, sir, why you have not uses in the NAND gate, NAND SR flip flop, you have used only the NAND, and here we have not uses the NAND, you have uses the AND, not NOR. It may be all should be the NOR. So, there is one problem. If I will be added, suppose here the NOR gate, then what will happens, you just imagine or see. I will make you very clear. So, see here, I have overwritten with the red sign pen. If here will be the NOR gate, see here the truth table of this NOR gate. The truth table of NOR gate is A plus B whole complement. If the input is 0 0 0 1 1 0 1 1, then 0 0, that is 0 into 0 plus 0 is equal to 1. 0 plus 0 is equal to 0, and the complement is 0 is equal to 1. 0 plus 1 is equal to 1 and the complement is 0. 1 plus 0 is equal to 1 and the complement is 0, and 1 plus 1 is equal to 1 and the complement is 0. This is the truth table of the NOR gate. And in this NOR gate, what is here? If the one terminal is fixed 0 and this is the another terminal fixed, if this is one terminal is 0 0, what we are seeing, another terminal, if this is 0, then there is the 1 changing, and if this is 1, then this is changing 1 to 0, 0 to 1. But when this is one terminal, I will make this like this. This is the NOR gate. Suppose one terminal is 0, this is 0, then what is happening? If there is 1, then output is 0. If here is 0, then output is 1. That means ki one terminal is fixed by 0, then whatever the input, output is going to be changed by just opposite. But if the one terminal will be fixed by 1, here this is 1, and the input will be 0, then output is equal to also 0. again the one terminal is again y1 and the output is 1, then again the input is 0. That means what we are seeing here, if the input is 1, if the input, the clock input will be 1, on that time whatever be the input, there is no changes on the output, it will come always the 0. But what we have written here, in the clock flip flop the output can be changed state when the clock is high. Here the clock is high, but the output is not changing, output is in 0 0. So we can't take, and in the 0 position this is changing, so due to that we can't add the NOR gate. So we have to move towards the AND gate and see the properties of AND gate. What is the truth table of the AND gate? So by this way this will be the cutted, it can't be used, and now I have made the truth table of AND gate. If this is the AND gate, this is the symbol of AND gate, this is one terminal, suppose this terminal is fixed by 0 and output input is 0, the output is also 0. If this is fixed by 0 and output input is 1, the output is again 0. That means in 0 this condition is not working, and if this 1 is 1, on that time the output is 0, then 0 and 1, then this is 1. So this is happening by the AND gate. So already you know, if the clock will be 0, S is equal to 0, R is equal to 0, what will happen in the AND gate? So here I will write here, this will be the 0, this is 0, this is 0, then one terminal this is 0 here and this is 0, clock pulse is 0 and R is 0. On that time when this is 0 0, clock is 0, already I have told you, if 0 0, then whatever be the input, it is 0. So here it will be 0, and again this is 0 0. By the help of that AND gate table we will see that this is the 0, and in 0 0 condition this latch, this is the latch of truth table of the SR latch using NOR gate. What is happening? This is the hold condition. So what hold condition means? The past state. What was on the QN? That was the output on the. So while the clock is 0 0, input is 0 0, the output is hold condition. Again see here, if the clock will be 0, S is equal to 0, R is equal to 1. S is equal to 0 already here, R will be 1, clock is 0, what will happen? If this will 0 0, this is 0, again this will be 0 1. We will see here, 1 I am applying, so output will be 0, again 0, and again it will go in the hold condition. So whatever, if till the clock will be 0, we will see whatever the value of S or R, that may be the 1 0, yeah 1 1, all this will be the hold condition. So what we will write here, for all these 4 condition, till the clock is 0, S is equal to X max, because there is the don't care, and I will drop this. You may write this 4 for the long table, it will be that, so I am just rubbing. You may write, no problem, as you wish, because the 4th condition is inside this. You can suppose, you can know very well. Okay, now the clock pulse will be 1. See what happened. Now, because in the clock flip flop the output can change the state when the clock will be the high. So I will keep this 1. That means this terminal and this terminal is 1 already, because this has connected each other. Now S is equal to 0, R is equal to 0. S is equal to 0, R is equal to 0. What will happen? If the input will be 0, here in this condition, the AND gate 1, just the same. So 0, so here will be the 0 and this will be the 0. 1 0 is 0. And again the 0 and 0 is S dash and R dash will be the 0 0, the output will be hold condition. and it will be the Qn. Are you getting? Okay. Now the next, again the clock will be 1, S is equal to 0, R is equal to 1. S is equal to 0, R will be 1. This one will come here 1. This is already 0, 0, 1 is equal to 0 by the help of that truth table, because the AND gate output will be the 0, and here is the 1 and 1. So, whatever be the input, that is the output. So, the 1 1, and when this dash will be 0 and R dash will be 1, in the truth table of SR latch we have already seen that 0 and 1, that is the reset condition. So, this will be the 0, and we can say this is the reset condition. Getting? Okay. Now, again the clock will be 1, or we should say trigger. 1 means what? Trigger. We are triggering the clock. Trigger, T-R-I-G-G-E-R. Now, S is equal to 1 and R is equal to 0. S is equal to 1, R is equal to 0. What it will be happen? If 1, then there will be the 1. If this is 0, this will be the 0. And we know that AND gate. And this is 1 and 0, on that time the set condition, and it will be the set by 1. So, this is the set condition of the SR flip flop using NOR gate. Now, the last one condition, and clock is 1, S is equal to 1, R is equal to 1, already S is 1 here, R is equal to 1, this is 1, clock is 1, what will come here? 0, because we are seeing here, 1 1, so this will be the 1. Again 1 1, here will be also 1, and when the input of this latch is 1 1, input of this latch is 1 1, and this is invalid. Invalid, we can say marked by the X, that may be the 0 0 1 whatever. So, what we have seen, if you will see very carefully the truth table of SR flip flop using the NOR gate and also the NAND gate, both the table will be the same. In latch it was vice versa, but in clock it is same. So, now remember, this is why we have used AND gate and NOR, not only NOR. I have made very clearly, because due to the in 0 clock pulse it was not working, in 1 only it will work. So, finally, this is our circuit and this is the truth table. So, if any inquiry, any comments? Okay, no one. Very good. Hope you will enjoy this lecture again. We will see the next lecture, the JK flip flop. In that topic, whatever the problem arises here, when the condition of 1 1 that was invalid, it may be solved in the JK flip flop. We will see later on. Till today, this much only. Thank you. Bye bye. Take care. Enjoy your life.